Hey guys, sorry it's so late and I'm just getting back to you, but a lot of you just wanted me to run through nonapeptides and how they're secreted and their actions. So this is what this video is for. I hope it helps. So first of all, start off in the pars nervosa of the brain. That's where the nonapeptides are secreted, or the posterior pituitary. The two major ones are oxytocin and vasopressin. And these are really interesting because oxytocin and vasopressin both have neurotransmitter capabilities as well as neurohormone capabilities. So I'm going to start off by talking about the neurohormone capabilities. For starters, oxytocin is a neutral peptide and has a cysteine base with disulfide bonds, and then at the 3 and 8 position, which are the ones that are most important that she kept harping on in lecture, you've got lysine, you've got I-lysine and lysine at the 8. Oxytocin is one of those drugs that's just really, really important for reproduction. It stimulates the contraction of most reproductive smooth muscles. So when it's in high doses in the blood, it's got to be during ejaculation, during orgasm, and of course for the women out there, for when you're having a baby. It also has a not well known effect, and that is the contraction of myoepithelial cells in the mammary glands, and that's going to increase milk letdown. And don't get confused with prolactin, because that just increases milk synthesis, not letdown. That's it for oxytocin and how it acts as a neurohormone. Now for vasopressins. If you guys remember, humans have arginine vasopressin, and most other mammals have lysine vasopressin, like hippos and pigs and stuff. The 3 and the 8 position, everything is the same systematically wise as oxytocin. So you've got the disulfide bond, the 2 cysteines, but then at the 3 and the 8 position, for arginine vasopressin, you've got Phe-arg, and for lysine vasopressin, you've got Phe-lys. The physiological stand on vasopressin is that it acts as an antidiuretic, whereas the pharmacological stand is that it increases blood pressure, and that's why it's used there. How does it do this? It's going to bind on the basolateral surface of a cell in the collecting duct of the nephron and in the kidneys, and when it binds there, it's going to activate ATP to transfer into cyclic AMP, and that cyclic AMP is either going to go to the nucleus for transcription, or it's going to activate phosphokinase A, and then it's going to go to the apical surface, pull aquaporins, which are already in the cytosol, up to the apex of the cell, or to the lumen, and they stay on the transmembrane surface, and then water moves from the collecting duct back into the bloodstream, and that's how it works, is it increases blood pressure because it increases the volume in your blood by adding water to it. That's it for how they act as hormones. So how they act as neurotransmitters and neuromodulators is completely different. So oxytocin, known as the love drug, makes things like people and animals and basically everything it's in monogamous with one another. So that's when you see like prairie voles, is what we talked about in class, and how they stay together for life as a couple. And it's because they have all this oxytocin, but they also have the receptors to activate this monogamous feeling for one another, whereas their cousins, meadow voles, don't have the receptors. So you can have all this oxytocin, but unless you have the receptors, it's not going to have an effect. Another thing it does is it increases lordosis in rats, and it makes the ooze want to nurture their young. And then for vasopressin, it's kind of mostly a male thing as a neurotransmitter, but what it's going to do, it's going to increase males' paternal behavior once a baby's born. It's kind of cool. It acts as almost a pheromone type thing where they sense the baby and their paternal behavior goes up, and it's also going to increase their aggression towards strange males. Alright, so if you guys have questions about this, just email me and I'll make sure to get back to you. Okay, have a good night.